here this month again. So what we'll just be doing today is just to continue from where we stopped in the last session. Yeah, that was last month. So we started the SQL class where we talked about quite a number of things with Shadrack. So today we'll be looking at the part two, well, let me say the session two of the SQL journey. And then really appreciate Shadrack for his efforts coming down, for his time to take us through all this. And then yeah, we're also having him today. So I hope Shadrack can hear me clearly.
Yeah, I can. I also hope everybody
Yeah.
can hear me clearly.
Yeah, definitely, sir.
All right,
Okay,
thank
you
you.
can shoot.
Okay, so yeah, again, thank you for having me. We started, or I handled the last class too, which was our last month's meetup, which was a fun introduction to SQL. We did quite a lot of things from going through the slides together, which is a lecture, and we also went hands-on. So today I'll be taking a step further um, by covering some of the things that we could not cover last month, and then also aside that, doing some of the things that we could not also discuss last month. So please pardon my voice. I'm a little um not so strong, but yeah, we'll go through this together. So again, just a quick recap. The essence of this month and last month's meetup is for us to get the essential SQL skills that will enable us to kickstart our data journey. So my name is Shadrack. I'm a data scientist. I'm a data analyst stroke data scientist. There's no how you be a data scientist that you know at first being a very good data analyst. So I work for CPI Tech, and I do have some other engagements, volunteering here and there, and also some consulting roles. I'm not so new to SQL. Worked with SQL for a while now, but my primary focus is NLP solutions. So I am actively working in the field, trying to build natural language processing solutions, especially for African languages, because we seem to be underrepresented in that area. So I know quite some tools. I know there are a lot of people on this in this call or on this call that probably know more than I do, but I know how to use Excel to an extent. Microsoft Power BI tool, Python, and obviously SQL, and Microsoft Azure. Just a little bit of Microsoft Azure. All right. So in the last meetup, we covered introduction to SQL, why SQL, SQL commands. We also spoke about SQL joins. We spoke about SQL aggregate functions, but we could not test run it or work with it. So today I'll try to speak about aggregate functions again. Then I'll take it a step or two steps further by talking about subqueries and temporary tables and also SQL date functions. So I won't bore us with the first four on the table of content because they are already in the previous meetup video, and the videos are up on YouTube just in case you missed that class, so you can always catch up on that. So I'm just going to go straight to aggregates. Okay, so again, we spoke about aggregate in the last month's meetup, but because we're going to be practicing it today, it makes more sense for me to do a little recap. So aggregate functions, or an aggregate function, is a function that whenever you perform on a range or a set of values, it gives you a single value. So whenever you are running an aggregate function like min or max, you are attempting to summarize to get a single value. Now, aggregate functions would always use them with a clause called the group by clause, which we are going to see when we get hands-on. So we always use the group by clause with aside the usual select and from statement, you would always have to include a group by clause, because aggregate functions, as we know, they are trying to summarize, and a group by clause will help you set your data, or in a word, aggregate it to give you a single value based on the conditions that you have set, or you have specified. So the group by clause will split it into groups. There's an advanced SQL function, which we will not be talking about now, that also does some of these kind of operations. But for now, the group by clause is much perfect for returning a single value in a specific group. So we have some of those functions, very popular ones: the mean, max, count function, sum, average. I mean, as data analysts, we probably we're not just seeing this for the first time. Worked in Excel, worked in Power BI, worked in Python, you would have seen most of all these functions. So the mean should return the minimum value in a set of range. The max should do the opposite. Count should return a set of should do like a count of the set of values that you have in a specified range. Then the sum too should add them up, and the average should return the average value in that set. Now, if you there's a note here at the end of this slide that says that all of the functions here, or all aggregate functions, they would always ignore null values except the count function. So the count function will count every row, including null values. So it's very important that you keep that at the back of your mind. They would also be working with subqueries today. Now, subqueries, they are simply put a query inside a query. So if you have a query, and a query, as we know already, is a very simple example of a query is when you try to get maybe a very a specific information from your table. Like, say you have a customer table and you want to know the names of your customers, or some selected columns in that table. Now that is a simple query where you write select first name, last name from this table. That's a simple query. Now, let's say you now have to write that query, but place it inside another query. So what you have just done is the initial query is the inner query, which is also called the subquery. So whenever I think of a subquery, it's like you keeping a query inside another query. Now, you might not think of how that might be possible now, but in a hands-on session, you see where that can come into play, where there are some questions you cannot answer straight on from just a simple query. You might have to use a subquery. Now, temporary tables, they are just like um, tables that you don't immediately store them, or the results are not exactly stored in the memory of your database. So temporary queries and subqueries very similar, because not exactly, they're not the same, but close, very close. They work hand in hand. Most times when you are learning about subqueries, you also have to learn about temp tables. So just basically put temporary tables, they are used to store immediate results, or intermediate results, pardon me. So you don't necessarily want to store maybe a set of return values in your database. So you use a temporary table. And one good thing about temporary tables is you can always call them. So if you store a temporary table and you alias it as something, you can always refer to it and use it even as a subquery. Okay, so that might sound like a lot, but when we get hands-on, it makes a lot of sense. All right, so just a little, should I say, a little thing to note. Both subqueries and temp tables, or table expressions, they are used, or they are methods for being able to write a query that creates a table, then write a query that interacts with the newly created table. So just like I said earlier about subqueries and temporary tables, they work very similarly. So if you create a temporary table and you store it as something, let's say for some specific reasons, you create a temporary table. Like in the data we'll be working with very soon, we have a customer table where the first name, the last name, they are on separate columns. Now, let's say you want to create a new table that would be combining both the first name and the last name together, and it will store it as a single column. And you want that information to stay in a table alongside every other column that was in the original table. Now you have subconsciously created a temporary table. Now you can save that, alias it as something else, then refer to it later, maybe in a subquery. So the idea behind running a temporary table is probably or most likely to refer to it, not to exactly store it in database, but to refer to it for use later on. Then the subquery tool would work very similarly because you would have to be creating a query inside a query. So that is how both of them can be very similar in operation. Again, please forgive me, not in my best today. But yeah, subqueries and temp tables, they work similarly just this way, where you are trying to write a query with the purpose of using it inside another query. Okay, so another thing we'll talk about is date functions. Whenever you want to perform date and time operations, you would always refer to a date function. It's virtually impossible for you to work as a data person and not use date functions because you always have to answer questions like how much sale did we make last month, last year compared to now? What's just time intelligence questions. So we have some functions that would help you attain this. We have get date, the date add, date div, date part. Now get date will always return the current date, like current date. And then you use a date add when you want to manipulate the get date, that's your current date, with reference to a specified date. So you use a date add, maybe you want to compare last month in your data compared to today's current date. So you would have to put like a get date inside a date add. Then you use a date diff, just like the name date diff is supposed to calculate the difference between some specified dates, maybe by day or by month. Then you use a date part when you want to fish out specific information, like maybe the day of a week from a date, or even a specific day, or maybe you want to fish out weekends or or quarterly information from your date. So these are the operations that you can work with for a date function. So all these other concepts, we discussed them in the last class. So I added this new slide in this overall slide because I realized that most of us, or a lot of us, are probably comfortable working with PostgreSQL, while some are comfortable working with SSMS. I use SSMS, which is Microsoft SQL Server. Some people are comfortable with PostgreSQL, but irrespective of wherever you decide to work, and if you are working with your Mac or your Windows, so this is just a little pointer so that when this slide is being shared with us, we can, for those of us that do not know how to get it installed and downloaded and installed. So this is just a helper function for us. All right, so before we dive in, I don't know if you have any questions. Yeah, I think in the last class I did say that you can always reach out to me on any of my social media. I'm on LinkedIn. I'm on Twitter as these names, so you can reach out to me there. And if you have any questions, please you can ask me now before we get into SSMS. Or should I still stay on this window in case there are any questions before we dive into the concluding part of this session? Any question?
Well done, sir. Sir, my question is, do we only have PostgreSQL only as the SQL database that we're using?
No, I don't think so. I don't think we have. I think there are quite a lot of other ones. They are. I might not remember off the top of my head now, but there's Transact SQL, TSQL, quite a lot of other ones. Yeah, we don't only have PostgreSQL or SSMS. I think Pelumi would probably know the rest, but no, we're not limited to this. But these are the most popular ones.
So are they probably did they have the same functions?
Okay, so yeah, that's a good question. Having the same function, yes, not all the time. I think in the very first class that we handled together, um, I did mention a little similarity and difference. If you're working with PostgreSQL, let's say you wanted to fish out the top 5 or top 10 information from a specific table, you would have to use something like the limit. So you write your query, say select this from this table. Then after that, you'd say limit of maybe 5 or 10. So that's PostgreSQL. But if you were to work in SSMS, you would use top. So first of all, you will not put the limits after you have written your select and from statement. In SSMS, you put the top function and you put it in your select statement. So they are very similar. Most if you're using TSQL, SL, PostgreSQL, whatever which of the SQL databases you decide to work from, they work similarly. You don't have to worry about, but there will be differences. But differences are not something that will throw you off balance totally because the same syntax work most times. It's just a little slight difference in syntax here and there, but on very few occasions. But it's something you can figure out. So if you are very sure, maybe you are someone that always worked with PostgreSQL, then you migrated to SSMS, then you encounter that kind of error with the limit and top, you can always figure it out, even if you don't know, maybe just quickly do like a research. But every other thing, syntax is very, very similar, like 90% similar.
Thank
I
you,
don't know if
sir.
that, yeah. Thank you too. So, is there any other question before we before we go before we go into our SSMS proper? Okay, so I'm going to take it as no questions, and I am going to minimize this. Um, yeah. So sorry guys, I might just have to switch off my camera. So it's like it's Swift. So there's a question. Pelumi, I don't know if I missed a question. I think someone is. Oh wait, is even Pelumi is asking you is like if inside if. Yes, it could. Yes, it could work similarly like that, like nesting a statement in a statement. So I'm guessing this question is for the subquery. Sorry, am I correct? I guess the question is for subquery. Pelumi on the call. Okay, wait, sorry. First of all, let me even confirm if you can hear me. Can everybody hear me?
Yes, we can hear you. I think he asked that question when you were talking about the subqueries.
Hi, Esther, can you hear me?
Yes, I can hear you.
I think I was scared for a moment that nobody was hearing me. Okay. Hi, Mr. Osman. Can you hear me? Mr. Musa, Mr. TMU. It seems like only Esther can hear me. Sorry, can any other person aside from Esther hear me? Just to confirm before I dive into this. Okay, sorry. Let me just confirm if Esther can still hear me. Then I just go ahead.
Yes, I can hear you.
Okay, thank you. So I'll just dive into it. All right. So first things first, just so it is always easy and straightforward, I always have my diagram ready, which is by the right. So this is like the schema diagram, um, which you can always generate for any of um your data or database. So in case you probably wonder how I got the schema diagram, just in case you're working with a database that does not have that already installed or fixed.
Sorry, Shadrack.
The last class,
Can,
sorry?
can you hear me? I
Yes,
don't
I
know if
can.
it's just me, but the screen that we are
Yeah.
seeing is your team screen.
Oh no, it should be my SSMS. How about now?
No, maybe it's my network. Let me just leave and rejoin.
Okay. Um, Sorry, I think I'd like if other people on the call can just say something because it seems like I have just Esther here. I don't know if everything is fine for everybody. Let me stop sharing first. Yeah, Mr. Osman, you wanted to say something?
Yeah, it's your team screen that we are seeing. Good afternoon.
Oh, thank you very much. So how about now?
No, we can't see anything. Yeah, we can see your SSMS.
Can see my SSMS. Okay, thank you.
Yeah, we can see it now.
All right, thank you very much.
Mhm.
Okay, so let me stylishly wait for Esther to get back in because I think she was the first person to alert us on that front.
Oh, I'm still on the call. I'm here.
Oh, you are? Oh, okay. So can you see the SSMS now?
Yes, I can.
Okay, thank you. Thank you for alerting us. All right. So back to what I was saying about the diagrams. Okay, just confirm again. Can you see this diagram?
Yes, I can.
All right, thank you. So I'm guessing everything is fine now. Okay, so like I said, I think if you probably don't know how we got this schema diagram, you can refer to the other video, um, where I think I did like a quick show of that. So now let's try to answer some business questions because I did create quite a lot of questions, which I think we should finish up. Should finish up in no time or before our time elapses. So let us first of all do total sales by year. Now there's a syntax to always follow. Now this is aggregations. This is SQL aggregation. Now this is why I said like the schema diagram is very important because you can always or will always refer to it when you want to answer questions because you would use the schema diagram to see or know the relationships that exist between tables. Now let's say this question says, or our manager is asking, what's the total sales by year? We want to see. So he's saying categorize total sales, but I want to see it by each of the year that our business has been in operation. So we know that definitely we have to write a select statement. Or this is how I try to think about before I answer a question logically. I have to write select statement. Then I have to obviously call it from somewhere, from a table. Now I go back to my schema diagram and then I say, okay, I want to know the total sales. Now the total sales, because I've gone through this table before now, and then there's only one information that is pointing to to pricing, which is the list price. So I'm going to be assuming that the list price is the total amount that was that each goods were sold for. So list price, in this case, or by our assumption, the sales amount is sitting in the sales order item table. And then if you look through all the columns in that table, we do not have any information on the year or the year of operation of our data set. So that tells us that we might have to do a join. So again, in case you missed the last class on join, you can always go back to watch the YouTube video on that. So it means that we'll have to do a join on another table where the other date is being specified. So, and the other date is in the sales table. Now, what's the relationship between both tables, the primary key and secondary key here? If you look through, if I try to zoom into this, you see that there's a key icon here. It specifies that this is the primary key on this table. And it is showing that it's moving in this direction. Primary key from the relationship is 1 to many based on this icon also. And then this tells us that the relationship between both of them has to be the order ID. So order ID, primary key here, secondary key in the other table. So that gives us the relationship, and then from there we go ahead. So I know that I have to do a join, and I also know I have to specify what I am joining or how I am joining by joining on something. So again, let's not lose sight of what the question is saying. So first of all, we are supposed to fish out some information. Now to the left-hand side of your data, you can always quickly try to see what's happening here, or try to see the kind of tables that are specified in a particular column. So let's say, for instance, right here, remember we're dealing with two tables, sales order item and sales orders. So I'm going to be selecting from the sales schema. And from the sales schema, I'm taking the sales order item table. I could rename this as something. Let's name it SORD, just so we don't have to always refer to this every time. And I'm joining the sales dot order table. And I'll just name this, okay, let's name this SORD. And let's name this SORD IT, just like sales order items. Now, the relationship, if you remember, as we said earlier, is, so I'm calling the table now, order ID, primary key, and secondary key on the other end. And then if I do a quick check on the order ID and other sales order table, sales order item table, I can see the columns are present in it. I am interested in the list price, which I would assume to be the sales amount or total sales or sales amount. Then the sales order table, expanding that to, I can see the order date. So I can just select and say sales, from the sales order table, I need the order date. But I just want to get only the one for each year. So I'm going to call the year function. And then I could rename this and say as order year. So now I have that. Then I am going to call my aggregate function, which is sum, because I'm trying to get the sum of the prices, which is list price in this case. And the list price is coming from the sales order item table, which is this. So I'm copying this to save time. And I'm just going to paste it and say sales order item. I'm going to paste it. Sorry. I'm going to paste it and call the list price. I think my IntelliSense just disappeared. Is it just me? So I'm going to name this What should we name this? I think total sales. All right. So now, if you look through this very quickly, you see that we have called an aggregate function that is trying to help us sum up the prices, and we're trying to aggregate them by the year. Now, after all of this, we have to call the group by function, because if you remember in the slides, we mentioned that a group by function has to be placed there. So that's going to be specifying what you are grouping your information by. So I'm going to be grouping by this, grouping by year. So just a quick way to always help you with the group by, or the columns that should be specified in the group by. Every column that is in your select statement, or the columns that you are interested in, they might not also be in your select statement sometimes, but the columns that you are interested in grouping by assigns the sum, assigns the column that was summarized or that was aggregated. That would be what you would specify in your group by. Again, it's not always the case where you have to group by a column that is in your select statement. But yes, you call the group by function, then you can go ahead and run this. So I'm going to be putting my semicolon because it's good practice. With or without semicolon, this would run in SSMS, but there are some other RDBMS where this would not work. So just so you are used to doing that. And also, just for readability's sake, I always write my functions in caps and then write my column names and tables in small letter. And I also try to space them on each line so they make sense and they are easy to read. So if you execute this, you get to see 2016, 20. So our business has only operated for 3 years. So we're just going to be assuming we're in 2018 or something. So our business has been in operation for 3 years, and this is the total sales for each of the years. So we made this amount of money in the first year, the second year is that, and the third year is that. So that just answers the question. Now, another question says, so is there any question on that? Or you can always stop me, please, anytime. If you feel that you are not understanding something, please, you can cut me. I'm willing to go over it. So another question says, average product list price by category. So again, we're trying to get the average of the product list price by their category. So if I go to my products, zooming out of this, if I go to my products table, I get to see that there's a list price, fortunately. So we probably don't have to do a join here. So there's a list price here, then there's a product name and product ID. So we can answer that question very quickly. So again, we have the select statement, we have our from, and then we have to group by because we're obviously running an aggregate function. So from our production table, which is in the production schema, I'm going to be calling that. Then production dot products table. Then from the production dot products table, we expand that. We get to see that we can call the product name, we can call the product ID, but let's just call the product name. So let's call the product name as product name, then the average of our list price. So I could alias this just so I don't have to refer to the whole thing. So I could alias this as P and then say P plus list price because I'm looking for the average of the list price, and then I want to group it by product name. And then I'm going to run this. All right, so let me rename this column because it's saying no column name. So let's just give this a name. Let's call it average price. All right, so now this is average price. So you can see that sometimes I use the AS for aliasing and sometimes I decide to skip it. Yeah, sorry, I think someone was asking a question. Somebody was trying to unmute. Okay, I'll just go ahead. So this will give you the average price of each of the products that we have. So we have about 291 of those, as you can see in the bottom corner of your screen. So this will tell you, okay, this is the average price for each product. Now, maybe we also want to know the total sales that we make per store. Maybe because we want to see or find out which store seems to be making the most money for us. So now going back to the schema diagram again, because this will definitely help. We have a store information. We have a store information sitting in. We have a store ID information here, and then the question, sorry, just checked again. Sales per store. So we have two informations that we need, but they are sitting in separate tables. That's the list price, which will give us the total sales, and the store ID or store information, which is sitting um in the orders, sales orders table. So to do this, although we could take this further by even adding a third table, because if you look at this table, we have sales, we have store ID, but there's no store name, and we have store name sitting here. So this tells me that if I want to know the name of the stores that are actually making the most money from this table, I might have to join the three of them. So in an interesting turn of events, I wanted to stop on these two tables, but I think we might have to join these three just so we know the name of the store. So there's a relationship between the three of them and it's moving in this direction. Uh, there's a primary key to a secondary key relationship here on the other ID column. And in this case, the relationship is the store ID. So let's try to do that. So it means that we are going to be writing a select statement from a table. We're going to be joining it on a table. We'll specify the relationship between the two of them. Then we're going to be joining a third table and we'll specify a relationship between them. So this is just so, it's easy to know that, oh, we're going all the way this way. So I'm going to be calling the sales schema. I remember I'm trying to join the orders table to the sales dot order item table. Let's call this sales ORD. Let's call this sales ORDIT. The relationship between them, if I am not mistaken, seems to be the order ID. So just to verify, yes. And these two is like order ID. Now on the third table, the relationship between the sales order and the sales store seems to be the store ID. So I'm going to be joining a third table, which is the sales store, and I will call this sales SST. And I'm going to be joining that to the sales order table, which is this. And the relationship between them is the store, again, to verify store ID. Yeah. Is the store ID. And I'm going to be joining that on the SST to the store ID. All right. So this has established the relationship between three tables. Now to answer the question, I just need the store name, and the store name is sitting in this table. So sst.store name, I'm going to alias this and name it store name. And then remember, we're trying to get the total sales. So we're obviously summing up the sales, and the list price is in the sales, the other item table. So sales, the other items table, shorten it to be this. Pasting this here dot list, sorry, the list price, and then we could name this total sales. So I am going to remember we have to group by, because we're running an aggregate function. So grouping by this, I'm going to group by this colon, and I'm going to run that. So this should answer our question. So this gives us the names of the stores and the total sales. So we could also try to order this information, maybe in the order of the people that are bringing the most money for us. So order it by the total sales. So that's what we're trying to sort. So order by total sales, but in a descending order, that's from top to bottom. So that's why I added the DESC. So executing this will tell you that the Bowden bike seems to be our most profitable store, but they seem to be selling way more than the rest. So I think so. I have a lot of questions here for that has to do with aggregation, but because I want to touch on every section, I think we should stop here for now for aggregation. But I think we have enough time. We might come back to it. But let's go to other things. Let's talk about date functions. Let's try to do something of date function. So if time permits us, we come back to the rest of them. So we have some questions here under the date function, which is we want to know the orders in the last month. We want to know the first order date, or the first day that our customers placed an order. We want to know orders on weekends. We want to know orders per day of week and a couple of other ones. But let's try to let's start from let's take it one step at a time. Now, if you remember, I said the get date function will always return the current date. So if you call the get date function, let's check it. So let's say I call I call select, then I say get date. And I just want to see. So if you run this, you get to see something. So you see that this gives us the actual date, today's date, which is 27th, obviously. 27th of July, 2024. And even the current time, as at the time I ran this. So this is telling me that, or telling us that the get date function will always return the current date. I just alias this as current date, so it comes out in that format. Now, what does this say? If we can always know the current date, then we can use that same information to answer some pertinent business questions, like comparing a date with respect to today, or going as far back as a year or a month, or any specific day. So now let's try to do something. Let us try to say we want to get the orders that were placed last month. So the last month meaning we're in July, so that's June. Now, if you want to answer such a question, the orders that were placed were obviously from, so we write our select and from statement, but orders were placed from the sales, from the order table. So we'll go to the orders table. And then we say, okay, you know what? Let us select all the orders that were placed. So using the asterisk would always give you all the columns as that are in this date in this table. So we say, I want to know all the tables that were placed in all the informations about orders that were placed, but for last month. Now, if you want to do that, you have to introduce a clause, which is the where clause, which I think we did. We used this in our uh last class here, the last meetup. So now I'm going to say, because if you look through the orders table, sales the orders, we have an orders date. Now is the orders date that I want to manipulate here. So I'm going to say, I'm specifying a condition that says where the order date is. So now this is where it gets a little, but you have to follow me carefully. So I'm going to be using some logical statements here that says greater than or equal to. So I'm saying that I want to know the orders in the last month, meaning from, we respect from today to a time like today, but last month. Now, for us to specify that, we're going to introduce a new function, which is the date add, which I think I did mention in the other this thing. Now, if you look at this, the date add is taken in, if you look at the information that's popping up on your screen, date add is going to take in interval, an incremental value, and an expression. So now the interval in this case is months, because we want to know the months. Now, the incremental value is -1 because we're trying to go backwards. That's backwards a month. But backward a month from what? From today. So remember, get date. Get date will always return today's value. So if you close this bracket, now what this would return is, I just want to think about it critically. Today's date backdated a month. So that is obviously a month from now. Now, this date add function, you remember when I said it would always return a manipulated date that you want. So the date add function is saying, give me last month's date. That's basically what all of this. Give me last month's date. But then again, we have a where clause that is telling us that check the orders date and make sure that it is greater than last month's date, greater than or equal to last month's date. So if this where clause is obeyed, what will definitely happen is we're going to be returning a date that is equal to last month and also above it, and is definitely going to stop on today's date. Now, if you run this, you're not going to get anything, Sha. So yeah, I know that you're not going to get anything, because if you remember, our database or our data is like from 2016 to 2018. So we don't have any information for 2024 in this data. But I wanted to really point this out so that you know that you can actually answer a question like this. So if you, let's say we want to specify, we're trying to answer a question based on the idea that we know that our data is not so it's not starting from, or it's not a recent data. I'll just go ahead and say I want the information for a specific date. So this time I'm just going to specify a date. So this time I'll just say where the other dates. So because now I know that the database is not, it's not very recent. So where the other date is, I'm going to specify 2018 or maybe June of 2018. So I'm specifying a range. You can use the between, but I just wanted to use this format. You can say where this is between this, but so I'm going to say I'm using logical statement that says greater than or equal to this date and another date, which is this. So you should also know the format of your dates in your system, because it could be very detrimental if you don't. So I'm going to run this, and then this should give us. Oh, sorry, there's a mistake in my colon. 2018. Oh yeah, sorry. I think I missed out this. So where this other date is greater than this and this other date is, sorry, this is the this is probably logical statement. So I have to think about it logically. So it falls within this range. Greater than or equal to this date and the other date is less than this date, yes. All right, so this tells us that we had just one order that was placed between June and July of 2018. Let's assume we're in 2018. But let's increase this to maybe June and August. So I'm changing this from 07 to 08. And we can see that we have about 5 orders between that specific time. So again, this is just to show that you can use this with respect to your current date. And I only use this because our data set is not falling in recent times. Now let's try to answer another time question here that says, what's the first order date for each customer? So this should not be so difficult to fish out because we're not using any specific function. So we could just say we want to know the minimum date that an order was placed by a customer. But for us to check that, we have order dates sitting in the sales table. We have customer information sitting in another table. So we might have to do a join to know the customer, maybe first name, last name, or ID, and then this. So to do that, we have a select from statement. We have a join because we're joining two tables on a condition. And because thinking about it, I just want to fish out the minimum date for each customer. I will definitely use a group by because calling the main function is an aggregate function. So let us say selecting customer information. So I'm going to check the relationship between both of them, and it's on customer. The customer ID is the relationship between both tables. So I'm going to go ahead and say from sales dot order, from sales dot orders here. I'm going to rename this as SORD. I'm going to be joining it on sales dot customers. Our name is S customer. And the relationship between them should be customer ID based on what we saw in the schema diagram. And this also should be customer ID. Now, because we're interested in the customer information, so I'm going to be selecting from the customer. I just want the customer customer ID email. I'm going to name this as customer ID. And then what else am I interested in? The mean, because we want to know the minimum date that an order was placed. So the minimum date is sitting in the orders table dot orders. I hope I'm not misspelling this order date. So let's name this as let's name this as first order date. So grouping by this, and we can run this. So yes, so this tells us that customer with customer ID placed the first order on this date, and customer ID 2 placed his first order on this date, and like that till we have all the customers and the dates that they placed their first order. So this is probably like our earliest customer. I'm not mistaken. I might be mistaken. Except I try to reorder this, maybe in ascending or descending order. So this answers that question. I think we should also try to let's do orders on weekends, because this we've involved using another date function. So this is straightforward, but please follow me carefully. So we want to answer a question. We want to know how many. We want to know the orders that were placed on weekends. Maybe for some reasons we just want to know orders that were placed on Saturdays and on Sundays. Now to do something like this, we have to call a select statement and say, first of all, before I answer that question, where do we have the dates? Okay, so the date is sitting in the orders table. So I want to see all the information for orders that were placed. Sales of orders. Orders that were placed on weekends. So now please watch carefully. I'm going to call a function date part. So if you remember, we have used the date add. We have used the date get. And we use the date get to call the most recent, the current date. We use the date add to manipulate our current date to fish out a date that we wanted. Now, date part, you can always call date part when you want to get out specific information like day of the week. Like day of the week. I think quarter information, stuff like that. So now there's a little I won't say function, but introduction, which is DW, that I just introduced. So DW is saying that day of the week. So DW is short for day of the week. So we're saying the interval is the day of the week, and then the column that we want to perform this operation on is the order date. That's the range that we're specifying. Now, something interesting that I want you to note here. We have specified the day of the week. We have specified the date that we are going to be taking our date part from. Now, just like I just introduced an operator, which is the in operator. Just like we know in the previous class where we use the in operator to fish out specific information in a where clause. You can do the same thing for a date function. SQL always counts day of the week. We have 7 days in a week. SQL always counts from Sunday. So it counts Sunday as 1 and Saturday as 7. Because it starts from Sunday, so it takes it all the way to Saturday. So that's 1 down to 7. So now day of the week also follows that ideology of 1 to 7. Now we are trying to restrict our own information to weekend. So we're going to be saying the day of the week, we want to fish out just 1 and 7 information from it. So 1 and 7, remember, is Sunday and Saturday, and that is weekend. So the moment you run this, you get to see dates for orders that were placed on just weekends. You can verify this order dates I think if you have a calendar, you can check it. 2nd of January 2016 should be a weekend. 3rd of January should be a weekend. 9th should be a weekend. So if you look at it, you most likely see that because we have 7 days between each of them. 2 plus 7 is 9. And then another weekend should be like 10. So 9 and 10, 2 and 3, 9 and 10. 9 plus 7 should be about 16. So we have a 16 here. So it should be 16 and I think maybe 17. And then, yes, I guess. But yeah, you can verify this though. So these are weekends. All the dates here, they are weekends on that specific date. So this is a quick way to know that, okay, so customer placed another on this day, which is like a weekend. These are all the information for orders that were placed on weekends. I don't know if there's any question so far. Or should go ahead and try to. I think we should try to answer another date question before I try to do sub queries. Maybe we should do quarter. Or maybe I should also try to ask. Okay, so maybe the next question I try to ask. I try to ask us what we think or how we can solve it. Okay, let's do quarter. So if I say sales for the current year, we'll have to use get dates, and we know that our table is not even is not recent. So if I use in the last 30 days too, I might have to use get dates. Our table is also not recent. So let's do quarter. Is there anybody that wants to try to solve this? Sales by quarter. Like all the sales that have been made, total sales. So we know that we have to get information from this table. Then, because we're dealing with sales now, so list price is sitting here. Then we also have to get date information from this table. So we have to do a join. Sorry. So we have to do a join. And for us to do a join, obviously we have to call the join on so function and the rest of that. But also very important, what else? We are going to be introducing a quarter. But I think it should be a little straightforward because we did something like day of the week here. So is there anybody that wants to attend this? Is there anybody on the call that wants to attend this? Maybe I should try to switch the call and see what's happening there. Sorry, let me minimize my window. Okay. Mr. Yinka, do you want to attend this? Or what do you think?
No, sir.
Okay, do you want to attend it? Sorry, I didn't get you.
I said no, sir.
No, sir. Okay. No other. Let me just forge ahead then. So so if we want to use the date part function, I'm going to be calling the select statement, and I'm going to be saying from the select from, I'll do a join because we're joining two tables here, and we're going to be joining them on something. All right, so going back to the schema diagram, we're trying to answer an information or a quarterly information from two tables, which is if I look through the table again, which is the orders table and the order item table. So list price, right? We're interested in list price information from the orders item table, and We're interested in the date information from the other sales table. So going back, I can see the relationship between them is the order ID. Going back there to say I'm joining from the sales dot orders table as SORD, just aliasing that, and I'm going to be joining into the sales dot other items table as SORDIT, and then the relationship between them is the order ID. So I'm going to be specifying that as order ID. Now I am interested in the quarter information. So I'm going to be introducing or calling the date part function. And I'm going to be saying, I want the date part function, but I want the quarter information from this table. That's the range of, and I want to name this as quarter. So I want that table to be named as quarter. Now, it's not always best to rename your information on functions that or predefined functions. So it's best, or it makes a lot of sense for us to rename this as something else. Let's just say order quarter. So order quarter, and then we're going to go ahead and say, because we're trying to get the total sales, we're going to say summation of the sales order dot the list price, because again, we're assuming that the list price is the sales that were sold as total sales. So I'm going to be renaming this as total sales. Now, I'm going to be grouping this because I already called an aggregate function. So I'm going to be grouping this by this. So this should answer that question. Oh, sorry, there's a mistake. So summing, did I invalid column name? List price is oh sorry, the list price is from this table, not, yeah, my bad. So running this should work. All right. So now this answers the question of the sales that we make quarterly. So it might be that we might just want to know that, oh, there's a specific, because the year, if you remember, the year is divided into 4 quarters. So it might just be that there's a specific quarter of the year that we make the most sales. So we can decide to order this by total sales. We can take this further by saying order by this colon, just so we can see it in, let's say, in descending order. So if you run this and you execute it, so we get to see that the very first quarter of the year we make the most sales, and second quarter of the year we make the next most sales. But this just gives you an idea that, okay, it seems like whenever the year kickstarts, that's when we get to make a lot of money. All right, so I think we can stop on the date functions. I think we can stop for now. Let's try to do or answer questions on subqueries and temporary tables. But before I forge ahead, so is there any question on this? Or any question so far? So I'm going to take it as no question. And delve into this. All right. So talking about subqueries and temporary tables now, there's a question here that I think I want to answer because it requires some critical thinking. Okay, which is this? I think let's answer this question. Product with sales above average. Now I'm going to run a subquery here, but running this subquery, like I said, requires some critical thinking, and then I think I want us to look at it carefully or take it. I want us to take it one step at a time. Now, logically, before answering the question, we want to know products with their total sales that is above the average of the total sales. So what it means is that we should first of all, because we don't have this kind of information sitting in our data set, so it means that we have to somehow create a temporary table, then run it as a subquery inside your table or inside a query. So what this means is we want to first of all fish out the total sales that we make, then the average of that total sales, then products that do better than the average. So what this means is, so let's take it from the inner query first. So let's try to first of all run an inner query that says, we want to get the sum of the list price from, because I know that the list price is sitting in our sales.order table. So from sales.orders table, because we've called an aggregate function sum, we have to call the group by now. So that says group by, we can decide to call this, okay, because we're dealing with products, we want to answer a product question, so it makes sense to group it by the product ID. Now remember, product ID is not sitting in how do I place this? Product ID is not, first of all, let's check the sales order table. So if you look at the sales order table, product ID is not an information that is sitting idly there, but because of the end goal, which is to get the list price by the product ID, we might have to specify this. Now, so let us carefully look at something. Calling the sum of the list price from as let's rename this. I'm going to rename this as total sales so that it helps. It helps. Now I'm going to do something that is a little, I hope it's not confusing, but please just follow me carefully. So I'm calling a select statement and I'm going to be nesting something. So because I want to know the average price of the total sales. Sorry, I call this total sales. So because I want to know the average price of the total sales, I have called this. Now, I'm going to rearrange this and say the average sales from a particular table. Again, please just follow this carefully because it can get very tricky when you want to nest something inside, but next a product, next a query inside another query. I'm going to name this as a subquery. So if you think of this logically, what's happening here is I have the sum of the list price from my orders table, and I'm grouping it by the product ID. And that is in itself like a query in a like a mini query. Then after getting the list price from that, I am now going to go ahead. Sorry, I think I might just be because I'm getting red lines and I'm wondering, I think I might just be referencing the wrong table. Yes, other items. So sorry. So in the other items, I have the product ID, I have the list price. Okay, this makes more sense. So if you look at this, let us try to run this. Sorry, trying to group by sales.orders item, group by product ID. Everything looks good. Sorry, this should run. Saying there's an error somewhere, but that should run. So what is basically happening is I want to run the inner query first. That is saying the sum of the list price from the sales.order. Yeah, I think I don't know if my query name is wrong. Other items, yeah. Group by product ID. Sorry, I'm trying to run. This should not be returning an error. Oh, sorry, I'm trying to make sure this is clean. Yeah, this should not be returning an error. But I guess my eyes is not catching the mistake now. But I will catch it. So yes, I think I see my mistake. Uh, forgot my select statement. Okay. Select the sum of this as this from this table, group it by this as a subquery. Yes. All right. So this is why sometimes it gets very tricky when you're putting a clause inside a clause. So, but basically what I'm trying to explain here is I'm getting the total sales from a list price and I want to group it by the product ID from this table. So it's like the product ID, because if you look at this table, the orders item table, we want to get the sum grouped by the product ID, although the product ID is not popping up in the query or in the final answer. But now this gives us the sales for each product. That's the total sales for each product. Then that is an inner query. Then on the outer word, we want to get the average of the total sales, which is this. So that is a query inside a query. But then again, it doesn't even stop there because the question is saying we want products that go above this value that we just specified. So what will happen is we are going to be calling our usual select statement, and we're going to be saying select the product ID, then obviously from our sales other item table. Then let us group it by. So the reason why I'm calling another group by here is because I'm going to be doing something in the outer query. I want to know the sum of the list price, and I'm going to be saving this as total sales. So the sum of the list price as total sales. So I'm going to be grouping it by the product ID, and I am going to be specifying a condition that says having. So please keep this query. Remember this query that we ran first. Just keep it and think of it as a subquery. So I'm going to be saying, remember this query that we ran first is giving this final value. So I'm going to be saying, having this sum of our new list price, but greater than this query here, this whole query here. So I could even try to close this value so that you think of it as a value. So if you run all of this, okay, so again, we might just be having, okay, yeah, so I think I see the problem. So if you run all of this, we just answered a very complex question, which I think I really wanted us to answer, because if you can logically think of this or solve this, you probably would have no problem with running a query inside another query. So we take it bit by bit. So breaking this down bit by bit again, we had to first of all fish out the sum of our sales. Then we now had to get the average of that, which is this. Then we now had to find out the products that were doing better than the average or above average. So that answers this question of product with sales above average. So I think that's a question that is as complex as it can come. I think I tried to answer maybe two or more, maybe just two more subquery questions, and then I'll call it a day. So I'll share the materials with Pelumi. I'll answer all the other questions that I can't answer because of time, but I'll share the materials with Pelumi and you can always catch up on them. So the videos will also be online and you can always reach out to me too for more questions. So, but let me try to answer two more questions under the subquery and temporary table question, and then I'll call it a day. So let's answer this high value question. So if we are to think of orders that are high valued, that's orders that may be based on maybe the condition of our business, the orders that we place as high values are orders that they are doing better than average or doing well above average. So what this means is that we are going to be writing another select statement that gives us the average price list, first of all, or list price. So the average list price from the sales order item table. So if you run this, you get to know the average price from the sales order item table. So now we want to know orders that do better than this price because they are the ones that are of high value because they do way better than the average price. So to do that, we are going to be selecting, as usual, information that are of interest to us. In this case, we just want the order ID from our table and we want the list price. So we want to see the price really and actually confirm that it's doing better than this particular price. And we know that this information is in the sales order items table. Sales order items, or we don't need to rename this since we're just working with one table. So now this is where this is where we try to compare. So we now call the where clause that says where our list price is greater than all of this information here. I remember the information there is this. So we're going to be nesting that. So if you run all of this, sorry, let me just put my semicolon. So if you run all of this, you get to see all the orders that were placed that do way better than the average price. So I think that is a very good question that we answered. So let me answer one more question and then call it a day. So let's say we want to fish out other details for a specific customer. Now, you might just quickly want to check the customers table to see the people that are in it. Maybe let's say we just write a select statement that says select, or let's just say we want first name and last name information. Select the first name and the last name from this table, which is the sales.customers table. So I just want to quickly know the names or name of some customers. So let us pick Lindsay Bean. So now let's say we want to get some other details for Lindsay Bean. We want to know maybe the order ID, the informations about orders that she has placed. So what we'll do is we'll need to have a table where we need to have a table that gets that information. So let's say we have a customer ID for Lindsay Bean. So I'm going to be calling that. I'll say customer ID of this person. Where I'm calling a where clause now that says where the first name. So this would really specify that we are being particular about Lindsay. Where the first name is Lindsay and the last name is Bean. And last name is Bean. So if you run this, you get to see that the customer ID for this particular customer, Lindsay Bean, is 6. So we can use this information and say we want to get the orders for the particular customer where the customer ID is equal to 6. So that means we'll keep this aside somewhere. Yeah, but we have it at the back of our mind that we're about to equate this to another table. So to do that, we're going to say orders information is being specified in the orders table. And from here, we know the customer ID. So we know the customer ID of this Lindsay being to the 6. So we can just say, okay, give us information for the orders. There's like order ID and maybe some other things in the order. Okay, so let's check it. Order ID. What other information do we think we should check? Order dates. Let's know the order dates. Yeah, what else should we be interested in? Let's say required dates based on this information that we can see to the left. And then maybe shipped dates. Shipped dates. So all of these we are going to be selecting from sales dot orders table. Now this is where we get to use the where statement or nesting a query inside a query, which is a subquery. So we say where the customer ID, remember customer ID for this particular person is 6. So we're going to say where the customer ID from this table is equal to this particular one that we did here, which is equal to this. So I'm going to try to try and caps this. So I'm going to put this in a. This makes more sense. It looks more readable. So this tells us that. Remember, this inner query is going to return 6, which is this value we have here. Now, if you look at the outer query, we're saying where the customer ID is equal to Lindsay, which is 6, we should return this other information. So if we run all of this, we get to see all the days that Lindsay Bean placed an order, the date that she said she needed it, and the day we delivered it. So the first order now she placed on the 14th. She said she wanted our order by 17th, and we delivered by 17th. So this gives us a very specific order detail for a customer. So I think I'll stop here for today, or for this month. So we have quite a lot of other questions that are sitting inside this document, which I'll be sharing with us, or Palumi will be sharing with each and every one of us. So this brings us here to the end of our meetup for this month. It was fun doing this. Very privileged to be able to share the little that I know on SQL with each and every one of us. So thank you very much for having me. So over to you, Pelumi. So like I said, I'll be sharing all of this information with Pelumi. I think Pelumi will share with everybody that has attended and those that would also be watching this as a recording later on. So thank you guys for having me again.
Can you hear me?
Yes, I can hear you. Although there's like a little feedback. Like, yeah, it's breezy, it's kind of windy on your end.
That's good. But can you hear me? How about now?
Okay, wait, can you say something else?
I said, can you hear me? How about now?
Okay, it's better, but there's a background noise, but it's much better than before.
Okay. Thank you very much, Shadrack, for today. I don't know if there's any question. I think it's only Esther that is currently on the call. I don't know if there's any question Esther would like to ask Shadrack before we close to the session. Hi, Esther.
Okay. Can you hear me?
Yes, I
Can
can.
you?
Okay, so this whole sub-query thing is like new to me. So I just wanted to ask, just for clarity before I now maybe go over the video and also do my research. So when you want to nest a query inside another query, it's the where clause that like houses the other query, right? That it's only with the where clause that you use to like nest the other query. I don't know if you get my question.
Oh yes, I get your question perfectly. So although it's not all the case, but yes. So if you are to use a specific, like in the examples that we have done so far, where we try to use like the customer example, where we wanted a particular information for that particular customer, we use a where clause because in that case, we wanted to equate a numerical value to another one. Now, it's not always the case where you use a where clause. You can use a having clause. Like there's one of the example, I don't know if you were on the call at that time. We had a very complex example that I did where I use the halving clause. So first of all, I had to calculate the sum of the list price. Then I calculated the average of that. Then I calculated on the outer query where the sum of the new table was greater than the average of the other one. So I use the halving clause. So it's not always, to answer the question shortly or in short form, you don't always use the where clause when you want to nest a query in another query. You could be using the halving clause. And sometimes you might not even use either of them. You might be using something else. So it just depends on how peculiar the case might be. Funny enough, there are some other complex functions, like maybe when you want to partition by date, like advanced SQL queries, where it gets even more deeper than that. But again, just to answer the question, it's not all, you don't always rely on the where alone. You can use having to.
All right, thank you so much.
Thank you for having me.
Okay, thank you. Yeah, I just believe most of these tools that we use, there is not always a one-way thing to it. Yeah, someone may use this and then another person using another thing, and they will also just arrive at the same answer. But it's just when it comes to the performance or how fast people is going to run, just matters. Yeah, thank you very much, Shadrack. I really appreciate your time, even when you are still under the weather, you still came to teach us, and we can see that you really care about us. So thank you very much. And then when the recording is out on YouTube, I would also share with us on the group, and then we will also see it on the different social media platforms. So, Shadrack, is there any other thing you want us to take us through on SQL, or you just feel we can end it from there?
Well, it's entirely up to the organizers. But these are the basic or the essential ones. I think any other thing from now might just be an advanced SQL class. But
Ah,
yeah,
okay.
it's not up to me, it's up to the organizers.